Hello, in this demo we'll see how we can implement a simple RESTful API using Spark framework. I created here a Maven module with the dependencies to the Spark framework. As you may see, we are using the Spark core framework, which is actually you will see that implementing REST resources with Spark framework is similar to what you do with Node.js using Express. I also use JSON, which is a JSON parser from Google. So, in our source main Java folder, I created a package for the server, and here I have a simple model. I call the class model, but it's actually a node. When I create a node, I need to specify the title and the content, and I also have an ID, which is a string. I generate a uniform unique identifier, create a random value, and store the GUID out of it. And I also have getters and setters for the properties that I have, except for the ID. I only have a getter for the ID. I'm not setting an ID once the resource is already created. Now, the reason you see the expose annotation here is because JSON allows you to actually say what fields you like to serialize and deserialize. So I have also created a repository, and you will see why I'm not serializing all the fields. My repository will store data in a JSON file, and I also created a dummy JSON with some input data to have some nodes already created and be able to add more. And this repository is using a JSON builder, a JSON parser actually, and builder. So I'm creating a new JSON builder just to be able to configure the serializer. I say that the builder should exclude fields that are not annotated with expose, and the reason for doing so is the following. When I'm creating a repository, I store the path to the file where the repository was coming from, but I don't like this path to be serialized in my repository. But I do like to have a list of models serialized by the repository. So this is annotated and will get there, but the path will not be stored on the disk. Now, when I create a repository and I have a static method for that, I will load from a file, and what I'm doing is that I'm taking the path of the file, I check if the file exists, and if so, I read from that path with the files all the bytes of the file. I create a string with that bytes, and then I use the parser to load from that JSON a model which is my repository. If there is no file at that location, I will create an empty repository, but then I also store the path of the repository. So each time I modify the repository, I will save the new version into that file. I have a method to deserialize a model, and it's just a generic one. And I also have a method to serialize a model. I have a private constructor not allowing anyone to create at compile time to create a repository, but rather I have a method to load one. And I have a method to save a repository, which is actually calling the parser to serialize my JSON out of this repository. I take the bytes and then I write the bytes into that path. Now, when I'm returning the models, because I don't want someone else to modify the list of my models, I just return an unmodifiable collection, an unmodifiable list actually. And then I also have some utility methods. You can imagine that when I'm implementing a create, read, update, delete scenario, I like to be able to retrieve a model by an ID. And what I'm doing, I take the stream of the models and then I filter them by a predicate which says if the ID of the model equals this one, keep it in the list, and I take the first one. This may return optional of the model because we might have none. Now, when adding a model, I have to specify what's going to be the title and what is the content. I just create a model with this data and then I add it to the list. I save the repository on disk and then returning the newly created model. When changing a model, I can receive the ID of the model that I like to change and a list of property values. So that's a map saying which property to be set to which value. This may be a fully update of the model if I supply all the properties, or just a partially update. So what I'm doing, I say, okay, I didn't change the model. Then I try to find a model by the ID. If I found one, so I do have a model, then I iterate through all the entries in the map and I check if the key, that's the name of the property, is title. Then I call the set title with the value and say that I changed the model. If the key is content, then I also call the set content of my model and I say that the model has been changed. So basically this is what I'm doing. Each time I like to update an object by setting some properties on it, and if I change something on my object, I do save the repository and then returning the change status. Now, when removing a model, I will receive the ID of the model, and I'm trying to find the model by the ID. If I found it, I remove it from the collection and set the remove flag to true, so that eventually this will save the repository, and then I return the status of the saved operation. So this is a quite simple repository using JSON to serialize and deserialize objects. Now, what I created here, it's a console server which is using Spark. I have imported statically a couple of methods from the Spark class, and as you may see, working with Spark, it's very familiar if you are already using Express with Node.js, although you are in that case you are writing in JavaScript, but in this case the Java code is similar to what you have with JavaScript. So let's take it one by one. First of all, I'm loading the repository from the project path, from a file in the project, and I also have created here a transformer which is gonna serialize as JSON the response of the methods. You will see later on how I'm using this. Now, we can even set the static file location, because Spark is using Jetty in background and it's able to deliver static content. So I just have to specify from which folder to take the resources, and that's all. It's not going to be the case with my demo. I didn't implement a web application to show it. I will use rather than a web application, I'll use an HTTP client like Postman. But nevertheless, you may easily set from where to take resources and serve them. Now, I configure the port on which to listen, and then I register some routes. And I'll have the following routes. I'll have a get on the URL of the collection. If I do a get on that URL, I expect to receive a list of all the items in the collection. If I do a get to the URL of the collection / the ID of an object, I'm expecting to get the representation of that object. If I do a put on the URL of the collection / ID of an object, I will supply as a body the content of the new content of that object, and I expect the object to be changed to that content. If I do a patch on the URL of the collection slash the ID of an object, and I have in my body, in the body of the HTTP request, I have a key value pair list of properties like a query string, then I expect those properties to be updated on that model if the model is present in the repository. If I do a delete on the URL of the collection slash the ID of an object, I expect that that object should be deleted from the collection, from my repository. So now let's let's take it one by one and see how those routes are implemented. As you may see, I have dedicated methods to register a route, one for each HTTP verb I can have in the protocol. So the main idea of REST resources is to use HTTP not just a transport protocol, but as an invocation protocol. So we map as much as we can our elements that describes the usage of resources, the management of resources remotely, we map them to HTTP elements from the protocol. So I register a GET handler. Each time I receive a GET on this URL, this callback will be invoked. So my callback will receive the request and a response container to generate the response. That's what I'm doing is straightforward. So I'm taking all the models from my repository, but the idea is that I should not respond with a list of models if I have no items in my repository. Rather, it's better to use HTTP status as much as possible. Don't let the client try to parse the response if you have no content to deliver. So I check if my models list is not empty. If so, I set the status of the response to be OK, which is 200. I don't have to do it actually. I'm just doing it on purpose for you to see that we are actually creating each element of the response. If I just return my models, by default the status will be 200. That's going to be the OK status. Now, one thing that's important though is to set the content type header, which describes using MIME protocol the type of the resource. By default, the type of my response should be text plain, which is not the case with my format of the objects. I'm using JSON, therefore I should set the content type to application JSON. But by default, Spark is calling the toString method on what I return here, and instead of seeing the JSON format, the JSON representation of my list of models, I will just see the result of calling the toString. Therefore, I registered here a response transformer. So what will happen is that after returning this object, the response transformer will be called with the argument that I returned here, and it's gonna serialize the model. And what it's returned by this is gonna be the JSON serialization of the model. That's the string representing the model. Now, if I have no content, then I deliver 204, which is actually the status for no content in HTTP. Be careful not returning null here. If you return null, then it will change the status to 404, which is not found. So just return an empty string and you will have no content delivered to the sender. Now, when I'm doing when I'm searching for a particular model in the collection, I like to have a parameter in the path, and the way you specify the parameter is the same as with Node.js and Express. So you just have a colon and in front of the name of the variable. So this is gonna be a parameter in the path just because you prefixed it with a colon. And the logic is quite simple. So we try to search by the parameter of the request from the path. That's gonna be the ID. If we manage to find the item, we just set the status to OK, and we just deliver the JSON representation of the model. We just take the object from the optional box and we serialize it with the JSON response transformer. Otherwise, we set the status to 404. That means we didn't find any of that object by the ID, and we just return no body. Now, when we'd like to create, I forgot to say that also we like to create an object. When we create an object in the collection, we do a post on the URL of the collection, and we have to specify in the body as query params, we have to specify the title and the content. So if we have this specified, then we take the value of these arguments and we try to add to the repository. We will get the created model in the repository, but instead of returning the content of the object, which is not the case, we just like to inform the caller that the object has been created. We set the status to 201, which is created in HTTP, and we need to specify where the resource is available. Something very important with REST resources is that they should be traceable. You should be able to access a resource via URL. They should be linked together. You should be able to know if when you create a resource in a collection, where that resource is available to be accessed. So we specified the location header, and the location should be an absolute URL. Because imagine that you receive the URL and you like to send that URL to someone else. So it has to know what's the name of the server, on which port the channel is opened, and where the resource is available as a context on that channel. So we take the URL of the request, which corresponds to this actually, together with the host and port and so on. It's an absolute URL, and then we add the ID, because we registered previously a route that if we supply this and we make a get on this URL, like this one, then you will get the content of the resource. If there is some parameter missing, then we will set the status to be 400. That means a bad request. When patching the resources, we will do almost the same. We'll take the same path, so the same approach. When doing a patch, that's a partial update. We update the resource identified by an ID, and we create a map with the properties that we'd like to set. So we iterate through the query params, and we just store in the map by the name of the property the value that the user set in the request. Now we are calling the method to change the model for the ID of the resource and the properties, and if we were able to change it, then we set the response to 200. Otherwise, the resource probably was not found, so we say that's a 404. That means the resource hasn't been found. Moving forward, when we'd like to do a full update on the resource, we do a put request. So all that we need to do is to, in case of a put request, we will have in the body of the request the JSON serialized format of the new content of the resource. So we take the body, that's a string, we deserialize it, and we know that we should take a model, which is our node. We create a map of properties to do like a partial update, but with all the fields, and we put the name of the properties and the value of the properties. Then we try to change that object by the ID, and in case we manage to do that, we set the status to be 200, which is okay. Otherwise, probably the resource was not found by the ID, and we set the status to be 404, that's a not found. And in either way, we return an empty content. Now, deleting a resource is straightforward. we map to an URL that's the name of the collection and the ID of the resource. And what we try to do, we take the params, that's the ID of the resource, and we do a call to remove the model. If we were able to do it, we set the status to be 200, otherwise probably the resource has not been found. So now let me just start our server and consume the methods that we defined. I'll just start this as a simple Java application, which is the fact it's a console application. And apart from the fact that it's saying the logger has not been configured properly, and that's an error, we are okay with that. I'm gonna try and fire up. I already started Postman. So in Postman, I like to let me just I just have some of the previous calls that I did. But anyway, I have created here a new request, and I'm gonna do a get. So the URL should be HTTP. I'm calling this on localhost. Let's just enter this, and I have my collection, which is called notes. Let's just do a send on this. So as you may see, I receive a JSON. If I look in here, I see that I'm gonna try to use the scroll, which is not quite nice to use it with this Postman. The screen is 4K, so you only see a part of it, but nevertheless. So the idea is that here I have my response, which is actually, if I see what is the headers of the response, you see that I receive an application JSON, the content type of the response, and the server it's a Jetty, and so on. So this is what actually the JSON format of the list of elements in my repository. Now let's just try and take an ID for an object and do a get, but this time I'm gonna use in the URL this ID. When I do a get, as you may see, I'm receiving the content of my object. So I'm able to filter the objects in the collection. Now let's try to do something else. So let's just delete the ID in here and try to see what are the whole nodes again. So I have four elements in my collection, but then let's just create a new one. Okay, so let's just do a post on the URL of the collection, and I have to specify what is the type of the request, and that should be form URL encoded. First of all, let's do a send without any arguments in the body. So it says 400, a bad request, something is missing. Then let's try to add the title. Once again, the title, and the title should be like title 5. It's a dummy one, and the content should be, why not, content 5. Okay. Now I performed the call, and I got a status of 201, which is created. And in the headers, I also have a location where the resource is available. So if I then copy this, let me just copy the whole value. Okay, if I copy this and do this time a get on that URL, I will receive the content of my newly created item in the repository, which is the one with the values I entered before. If I like to update this, I have to do then, let's just copy this and update it. So let's just do a put. I'm gonna update the whole content of it, and in this case I will do a put on the URL of the resource together with the ID, and I have to specify what is the content type. In this case, the content type is the content type of the body, and it is application. I'm gonna send a JSON, so it's application/JSON, and in the body I need to access not a value type, but the body should be accessed as a raw value, and I'm just setting what is the value. Let's just update this to title X and content X. When I do the call, and let's just try and see what is the response. You see that I have 200, which is okay, and I have nothing except that. So it's just saying that the result was processed okay. But now let's just do a get on the same URL with the same ID of the resource to check if the resource has been changed. I'm getting an application JSON object, and this is the body of the object, and as you may see, the resource has been changed, and this is the new content of it, the one that I supplied as the body of my put request. Now let's just delete this by the URL with the ID of the resource, and then just do the call. I receive a 200, so it was okay. Now let's just try to actually do a get on the same URL, because the resource should not exist any longer. So in this case I receive a 404, that the resource has been deleted. And if I check, if I go and do a get on the URL of the collection, I should have only the 4 values without the one that I created. So basically, working with Spark is quite easy. You register routes in the same way that you do with Node.js and Express. You have callbacks that are invoked to generate the response, to create the response for each request when a route is accessed. And you have to use as much as possible the elements of HTTP protocol with respect to REST specifications. So that's all. Thanks.